So what happens when the brain is damaged by maybe a stroke from having untreated high blood pressure or diabetes, or from a brain injury from a fall where bleeding may occur in the brain, or nerve cells may get disconnected from each other? Or what happens if there's an injury to the spinal cord, like a gunshot wound that severs the spinal cord and causes paralysis below the level of that spinal cord injury? How is it that somehow people can still improve? Well, this is what we call neuroplasticity. This is the notion that the brain and the spinal cord actually can adapt to new circumstances based on same mechanisms of learning a new skill or remembering something that you've heard about, using those same mechanisms, but having to work a lot harder to regain those movements or those memories or that language that may have been disconnected a little bit by the injury. So here, for example, I'd like to show you a functional magnetic resonance imaging scan of a young person who had terrible epilepsy. The epilepsy was so bad. Epilepsy is a seizure, abnormal electrical activity, but it's coming from one side of the brain due to what's called an encephalitis. It got so bad that this person couldn't stay awake and couldn't learn anything new because seizures kept occurring and interfering with this person's attention and concentration and learning. It was like an electrical storm that basically took over the one side of the brain and kept the other side from working. Surgeons came up with a way to fix this, and by removing half of the brain, the half that was damaged and causing the seizures. Now you would say, well, if you removed the whole left side of the brain or the whole right side of the brain, you would have paralysis of the other side of the body. You might lose all kinds of functions. But interestingly, in young people, you can do something like that and have very little damage done, in part because of the adaptations or plasticity of the brain. And essentially what happens is one side of the brain starts to manage many different functions. What I'd like to show you is the changes that occurred in the area that represents the leg for walking, in which one side of the brain, one small area, became able to control both legs simply by a lot of practice, a lot of skills training, and with the fMRI we can actually show you exactly where those changes occurred. This is the right side of the brain, this is the left side of the brain, even though it's reversed. And this is for radiological convenience, but we see the entire right side of the brain is removed. If that happened to an adult, you would expect the left side of the body to be paralyzed. Instead, this youngster wasn't paralyzed. When this youngster tries to move the ankle on the left side, it's the left side of the brain, here in red and orange, that does the movement. When this youngster moves the right ankle, which normally would be controlled by the left side of the brain, we see this larger activation, which is more typical. With training and practice on trying to be make more skillful movements with the leg, after the training, just 2 weeks of training, what we see is a large expansion by recruiting additional nerve cells so that when here, the left side of the brain now controls to a better degree both the right and left legs. So now instead of the right brain being available to make a movement, we see in red that the left brain is moving the left ankle. So even having removed one side of the brain, this person was able to recover the movements on both sides of the body and live really quite a full life, play, sports, and do all kinds of school activities. So one of the lessons in this very superficial way of describing how the brain works is to keep in mind that things like practice, rehearsal, repetition, trying to integrate what we are thinking about, what's new and novel that we're learning, all of this can come together to enable you to achieve greater knowledge, more skillful movements, better activities, and improve the quality of your life. We try to use these things, these notions, to improve the movements and quality of life of people who have brain and spinal cord injuries as well. I hope you take advantage of some of this information in your school classes and your outside reading to learn more about brain function. I've barely scratched the surface, but if you go to the Brain Research Institute website at www.bri.ucla.edu, you'll find lots of other examples of ways in which you can come to understand the brain and even participate in school activities with undergraduate and graduate students in the Brain Research Institute at UCLA.